Okay, this is the first page after the warm-up. So we're going to use the different formulas that we've been talking about. So here they've told you that the probability of A is 1/2 and the probability of B is 1/3. Okay, and they want you to find the union of A and B. Okay, so the union of A and B is, if I was to draw a picture of that, here's A, here's B. The union of A and B is this whole region, right? They're united. So what is the union of A and B? It's that whole region. So basically, I'm going to use the law of probability. And I'm going to say that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of the intersection of A and B. We have to subtract it because we don't want to count this overlapping portion twice. Now, here's the thing. If it's mutually exclusive, then my circles don't overlap. If it's mutually exclusive. So if it's mutually exclusive, this means that the probability of A intersection B is equal to 0. They don't intersect, so the probability is going to be 0. So that means this right here is 0. So when we have mutually exclusive events, then the probability of A union B is simply the probability of A plus the probability of B. That's it. The intersection doesn't matter if it's mutually exclusive because there is no intersection. So now I've got 1/2 plus 1/3. We need a common denominator, so I've got 3/6 plus 2/6, which is going to give me 5/6. Okay, now let's do part B. What is the probability of A union B given that A and B are independent? Okay, oops. So let's write the law of probability again here. A union B is equal to probability of A plus probability of B minus the probability of A intersection B. Now we know that this is not 0. Now from our formula here, we know when we have independent events that A intersection B is equal to the probability of A times the probability of B. Just like in our example, when we rolled the die and tossed the coin, the probability, we multiply the two together to figure out the intersection when they're independent events. So we're going to use this formula to figure out the intersection here. So what we can do is we can say for independent, we can say that the probability of A intersection B is equal to the probability of A times the probability of B, which is equal to 1/2 times 1/3, and 1/2 times 1/3 is 1/6. and I'm going to replace this here with 1/6. So our intersection, our independent, the probability of A intersection B when it's independent is probability of A times probability of B, which is 1/6. So to figure out the union, we're going to say probability of A, which is 1/2, plus probability of B, which is 1/3, minus the intersection, which is 1/6, and then we are going to get our answer. We need a common denominator, so we get 3/6 plus 2/6 minus 1/6, and we end up with 4/6, which can be simplified as 2/3. Either answer is fine. Okay, let's do the next one here. The probability of A is 2/5. The probability of B given A is 1/3. So let's look at this for a second. And they want you to find the probability of B. Okay, we'll use this one in just a minute. So okay, the probability of A is 2/5. So the first thing I'm going to do is I'm going to use the formula here. The probability of A given B is equal to the probability of the intersection divided by the probability of what's given. So here I've got probability of B given A. The formula is going to be the probability of the intersection, B intersection A, divided by the probability of what's given, which is A. Okay, now we know that this here is 2/5, and we know that, let's pick a different color. We know that this right here is 1/3. So this intersection here, A intersection B, that's going to give us this right here. Okay, so we're going to rearrange it to solve for the light blue value. So if I multiply the yellow value on both sides, then I get the probability of A times the probability of B given A is equal to the probability of B intersection A. I just took this equation and multiplied the yellow value on both sides of the equation so that we can solve for this value here. So let's substitute and get the value now. Okay, so now we've got 2/5 times 1/3 is going to give us 2/15. So that's the value of this space right here, is 2/15. Okay, now we need to figure out this other region here. And we've got this given to us, the probability of B given not A. So the probability of B given not in A is going to be equal to the intersection of B and not in A divided by the probability of not in A. Now you might be wondering, why am I using this? This is going to give me the probability of being inside B and not in A, which is this space right here, right? This is not inside A, and it's the probability of being in B. So we're going to solve for the probability of being in B and not in A. And we know this value because they told you it's 1/4. And how could we figure out this one here? Running out of highlighters. If you know the probability of A is 2/5, if the probability of A equals 2/5, then the probability of not being in A has to be 3/5. Why? Because 2/5 and 3/5 is going to add up to 1. You're either in A or not in A. So I'm going to replace this value here with 3/5. But we're solving for the orange thing. So let's rearrange this equation so that we have the probability of A prime times the probability of B given A prime equals the probability of B intersection A prime. Okay. So all I did was multiply both sides of the equation by probability of A prime. We're solving for this orange value. We know that this one here is 3/5, and we know that this here is the pink value, which is 1/4, right? We know that that's 1/4. So we multiply this together, and we get 3 times 1 and 5 times 4, which is 20. So we know this region here is 3/20. Okay, so now I know this is 2/15, 3/20, so the probability of B is simply adding those two. So let's do that. So probability of B simply is 2/15 plus 3/20. So we need a common denominator, and we get 8/60 plus 9/60, which is equal to 17/60. You may want to hit pause and think about that. Okay, let's do question B now. What is the probability of A intersection B prime? Okay. So, A intersection B prime is A. Let's draw a picture to help us with this. A intersection not inside B. So that's going to be this region right here, because it's inside A and it's not inside B. Okay, so how do we figure this out? So we know the probability of A is 2/5. So this whole circle is 2/5. And if we subtract the blue region, then the light blue region, then we're going to have this part right here. So what I'm going to do is this is going to be equal to the probability of A, that's the whole circle, right? Minus the football-shaped wedge. And the football-shaped wedge is 2/15. This is the probability of A intersection B. So So we can replace this with 2/15, and we can replace this probability of A with 2/5. And so now we know that the probability of A intersection B prime is this region that's shaded here, the yellow portion here, not including the football, which is 2/5 minus 2/15. Let's get a common denominator. 16/15 minus 2/15 is equal to 4/15. I'm going to do the other pages on a separate recording.